Good morning to all. So in the last lecture, we were discussing about agents and environments. What is the difference between agent program and agent function? Then what is table-driven agent? Why table-driven agent is not used in real life scenarios, as it requires so many entries or few tasks which human beings can perform easily. So that is the reason we avoid table-based agent approach. Then simple reflex agents are there. The simplest kind of agent, and it responds to the present input only, ignoring the rest of the perceived history. For example, the agent performs the sign of something, sign of the input. Say input is 0, it will find sign of 0. If it is 45, it will find sign of 45, like that. Simple function is the agent function, and it responds to that, ignoring the history. So this is one kind of agent, simple reflex agent. So typically there are condition action rules, like if car in front is braking, then initiate braking. Okay. So these rules are there, just stored, and it will refer to those rules, but it will respond to the present. Like this. So what the world is like now, then there are rules, and what action should I do now, and the actuators will reflect that action. The functional representation of simple reflex agent. Then model-based reflex agent. The most effective way to handle partial observability is for the agent to keep track of part of the world it cannot see now. That is, the agent should maintain some sort of internal state. Like some part it observed earlier. So it will save that state. And it becomes the perceived history. And it becomes the model previous state. And then using that model as well as present state, it will take the decision that what is to be done right now. Okay. So that is the agent should maintain some sort of internal state that depends on perceived history and thereby reflects at least some of the. So here is the block diagram of model-based reflex agent. Here the input will come, it will come through the sensors, and the question is what the world is like now. So it is current input. Then earlier state, earlier how the world evolves. This information is stored. What my actions do. So this history is stored. That for then, in addition to this, condition action rules are there. So using all these things, model-based reflex agent will work. Okay, this action will be taken. So there are some scenarios where some part of environment is not visible or not available to the sensors. Okay, and that's why we have to depend on various inputs. One example is background subtraction. So for background subtraction, what we have to do, we have to check current frame and previous frame, and we find the difference between the two, and then we can know that whether there is movement or not. Now sometimes what happens that there is small change in the camera view. It may be due to noise or due to some small object that is moving, and because of that small movement, the machine says that, oh, there is a change, because pixel wise there is a change between these two frames, but that is very negligible. So that's why we have to use model based agent, which will keep history of say previous 5,000 frames, whether there is some change in 5,000 frames or not, and then only it will reflect that into the action. Okay. So we have to build the model. We are going to build that model. MOG is the name, mixture of Gaussian model for background suppression. This is the model we are going to discuss later on in last module. So this model-based reflex agent, it has percept as input. It returns the action to the actuator. What is persistent is what is keep on changing, that is state, model, rules, and action. This keep on changing. So how they change? State is equal to update state. So for this update state function, we have state, action, percept, and model. These are the inputs. It will give the new state. And rule. State and rules, these are matched, and exact rule is found out. And for that rule, what was the action that was taken, that is computed, that is retrieved, and that action is returned. Then next is goal-based agents. The first was simplex agent. Next is model-based agent. Third is goal-based agent. Knowing something about the current state of the environment is not always enough to decide what to do. For example, at a road junction, the taxi can turn left, turn right, or go straight. The correct decision depends on where the taxi is trying to get to. In other words, as well as a current state description, the agent needs some sort of goal information. Like if we want to go from a destination, from location A to location B, where B is the destination, then we may set the Google map. So B becomes our goal, A becomes our starting point, and the shortest path is calculated and reach the goal. So ultimately, to attain the goal, these agents they take the actions accordingly. So such agents are called as goal-based agent. Here, the agent needs some sort of goal information that is that are to be completed. For example, being at the passenger's destination. So say passenger books the cab, and this cab takes the passenger and reach at certain destination. So that is one of the desirable thing from goal-based agent. So here what the world is like now. So this current input, then previous state, how the world evolves, what actions are taken, what it will be like if I do action A. Will it fulfill my goal? Will it complete the performance metrics that are required to achieve my goal? So this is taken care of, and it is compared with goal and then what action is to be done. So this goal-based agent. Next is utility-based agents. So goals alone are not enough to generate high-quality behavior in most environments. For example, in many action sequences will get the taxi to its destination, thereby achieving the goal. Now, to reach destination B from destination A, say there are three routes. Route A is the route which is shortest one, so you'll require less amount of diesel and less amount of time to reach from A to B from route 1, which is shortest. But there is problem in that route. Problem is the road is not good and the road is not safe. So although we can reach from A to B quickly, that path is not safe, or that path is not good for the customer's point, from the customer's point of view. So we have to avoid that path, although it is cheaper. So goal will be achieved. What is goal? To reach from A to B. From the owner's perspective, it should be cheapest one, so the profit will be maximum, right? But goals just provide a crude binary distinction between happy and unhappy states. More general performance measure should allow comparison of different world states according to exactly how happy they would make the agent. Because happy does not sound very scientific. economists and computer scientists use the term utility instead. Okay, so in the end, whoever the person that is utilizing the agent, it should be satisfied with the route which is not cheapest. Say route 2 is there, which is somewhat longer, but the road is good, safe, reliable. So in the that road can be preferred. So it will end up in happy client. Plus, the owner may not be that much happy, but that may not be sad. If you take route 3, which is longest, so in that case, the owner may not be that much happy. Okay. So like this, the utility-based agents, they find the path, or they find the set of operations to reach the goal by taking into consideration all these things. So here you can see sensors are there, what the world is like now, so current state, and then the previous states, how the world evolves, what my actions do, what if I take, what it will be like if I do action A, and then utility. So this utility, earlier it was goal, now this is utility. How happy I will be in such a state, what action I should do now, like this. This is the utility-based agent. Then there is learning agent. So in learning agent, the environment is perceived via this critic block, the feedback, whether some input is given that up to the mark or not, it is good or not. If it is good, then learn from it. Okay, learn from it and make the changes, and those changes are reflected. Then here, before reflecting that, actually the problem is generated. Learning goals are there. Okay, so learning goals will give us the problem, and according to both these things, changes and the goal, the action is reflected. Okay, and this there is a feedback from performance element to learning element. So there is continuously improving. So this is learning-based agent, like reinforcement learning, which is part of machine learning, where if you do good thing, there is reward. If you bad thing, there is penalty. And in this way, the agent has to evolve. So these are learning-based agents. So these were the agents. So till now, we have discussed about many types of agents. Table-driven agent, simple reflex agent, model-based agent, goal-based agent, utility-based agent, learning agent. That's all. Okay. So regarding this, please go through this book, Artificial Intelligence: A Modern Approach, third edition by Peter Norvig and Stuart Russell. Okay, so this book is really good for this part of our syllabus. I request all of you to please read this book in detail regarding the agents, environment, types of agent. They are given several examples and try to solve the unsolved problems given in this particular book. All right. So this was one part of our syllabus. Next is Python programming. So regarding Python programming, we are already discussing this in lab. Okay. In theory, we will discuss about few typical things which are important. In interviews or in multiple choice questions, they may ask you such things. So some typical things we're going to discuss. So I request the classroom participation for this particular part. Okay. So 4 into 3, answer is 12. Next line, if I type like this, what will be the answer? What will be the output? is typical one. So this underscore, it will store the last answer. Interactive Python, it will store the last answer. So if you 12 plus 5, that is 70. Answer will be 70. Okay. Then reserved words. So we have some words which are reserved. We cannot use them as variable name or any object. So over here, these are a list of the words. So you have to remember these words. While programming, please don't use these words as object names. Like and is equal to 2. If I am trying to assign value 2 to and, which I am treating as variable name, it shows the syntax error. Okay. Next is number systems. So a number with prefix 0b is considered as hexadecimal. Okay. Prefix 0b is known as hexadecimal, and 0o is octal. 0o is octal. 0x will be hexadecimal, 0b will be binary. So for 60, we can write 0b and this entire thing binary. This is octal and this is hexadecimal. 3c is hexadecimal. So here it's a typing mistake. Here it should be binary. This 10e2 and 10e2, if e small, e is capital, doesn't matter. Both of them will create the floating point numbers. Kindly note this. If e is small or capital, doesn't matter. Both of them will create the floating point numbers. Then AND operators. So this 4 and 4. So how it operates? It converts this 4 into binary representation. So what is binary representation of 4? 0 1 0 0 and 0 1 0 0. So answer will be 0 1 0 0. So same logic, tell me the answers for this 1 and 4. What will be the answer? 5 and 2, what will be the answer? Convert this 1 and 4 into binary. Find the answer, convert it into decimal. Reply with your answer in the chat box. Question is, what is the answer for 1 and 4? Second question is, what is the answer for 5 and 2? 1 and 4, answer is 0. Okay. Okay. 5 and 2. Okay, we will check. Yes, correct answers. 1 and 4, answer is 0. 5 and 2, answer is 0. I hope all of you understood the logic behind this. Then find the answers for this. 5 and 2, no need to find. This 11 and 3. 5 or 2, 11 or 4. 5 XOR 2, 11 XOR 3. Be quick. Reply with the answers in the chat box. 53 students are attending this lecture. I expect answers from everyone. Be quick. If you have doubt, you can ask it. Try to solve it over some page and then you can answer. Okay, okay, very good. So now let us match the answers. 11 and 3 answer is 3, 5 or 2 answer is 7, 11 or 3 answer is 11, 5 XOR 2 answer is 7, 11 XOR 3 answer is 8. I hope all of you got the same answer. Next is left bit shift and right bit shift. Like if 2 is there, 2 is a number, and we want to shift it to right by 1 bit. Shift it to right by 1 bit. So how to do that? Paintbrush is if 2 is a number, so for 2, what is binary? 0, 0, 1, 0. If I want to shift it towards right by 1 bit, how it will be? Right. So here what happened? This 0 it got ignored, then 1 will come over here, 0, 0, and 0 will be appended over here additionally, but this 0 gets vanished. Okay. So this is shift right by 1 bit. And what is the equivalent, decimal equivalent of 0001? That is 1. So that's why answer is 1. Then the same 2, it is here. So for this, the binary is 0010. Here it is shifted like 01000. So it is shifted like this. So this is ignored. Come over here, come over here, and 0 will be appended. And then what is the decimal? 0010. So answer is 4. So you can check answer is 4. So this shift left by 1 bit, shift right by 1 bit. Any doubt? Any query in this? Do you proceed? So for this, can you find out what is the answer? 5 shift left by 2 bit. So for 5, you have to write like this: 5, that is 0101 shift by 2 bit. First shift left by 1 bit and again by 1 bit, and then we will match the answers after converting it into decimal. Please try. So answer is 20. Okay, let us check. Yes, correct. Very good. So for this 50, shift right towards right by 3 bits, it is 6. You can verify this later. The next is, it is important to notice that what happens when you mix standard numeric types, adding an integer and floating point numbers. For example, if needed, Python first coerces, that is converts either of numbers according to these rules, stopping as soon as the rule is satisfied. If one of the number is complex, convert the other to complex. If one of number is complex, convert the other to complex. If one of number is floating point, convert the other to floating point number. Like 3.0 and 8. This is floating, this is integer, answer is floating. Internally, it is converted into floating point. Then the operation is performed. Then here, this is complex number and this is integer, this is complex number. So internally, this 1 is converted to 1 plus 0j minus 1 plus 2j. So answer is minus 2j. So these are the rules of conversion, internal conversion. The next is this do more command. So if you want quotient and remainder at the same time in the form of tuple, we can have the quotient and remainder in the form of tuple. So 5 divided by 2, division is 2, remainder is 1. 6 divided by 3, division is 2, remainder is 0. So this do more command. Next is power command, POW of 2, 3. So 2 raised to 3, 2 raised to minus 3. This can be achieved using POW command. The next is multiple assignment. This is possible in Python. So here a comma b comma c is equal to 5.5 comma 2 comma 10. So what will happen? This 5.5 will be assigned to a, 2 will be assigned to b, and 10 will be assigned to c. Like this. So at the same time, we can have multiple variables and we can assign values to them. Next is you can also use multiple assignment to swap any number of variables. Like if you want to save C to A to B, B to C, it is possible. Earlier, A was 5.5. We swapped A with B. Okay, we swapped A with B. Now B becomes 5.5. And likewise, it works for other variables. Okay. Then augmented assignment. In C++, this is typically popular type of assignment. So A is equal to 10. A plus is equal to 5 means what? A is equal to A plus 5. A plus is equal to 5 means A is equal to A plus 5. So A becomes 15. Likewise, like this plus equal to, like that, there are multiple augmented assignment operators. And Python doesn't restrict you to just 2 operands. In comparison, for example, you can use common A less than B less than C notation common in mathematics. If A is less than B and B is less than C, so you can combine it in Python, okay, and you can compare. So here A is less than B, B is less than C is true, so that's why answer is true. Here A is less than B is true, B is greater than C, this is also true, so that's why answer is true. So you can write like this. You can have the multiple comparison in the same line. Right. So this is the power of Python. These operator precedence. So you must remember these which are the operators and which has the highest precedence, like that. So this is just a table. You should have this for the reference. Plus minus multiplication, like this. String literals. Over here, string literal is sequence of characters enclosed by matching pair of single and double quotes. So here this is match. It begins with double quote, ends with double quote. Okay, fine. Begins with single quote, ends with single quote. This is also fine. But begins with double quote, ends with single quote. This is not allowed. This is not allowed. Next is say in a line if you write 3 strings. Okay. They are separated by white space, like there is one space bar over here. You write like this and hit enter over here. Then what happens? The Python combines these 3 strings into one single string, 1, 2. So this happens. Next is while writing a code, if you give backslash like this, ABC backslash PQRZ, then it will treat it as single string, which is included within double quotes like this. Okay. So what will happen? It will combine all these things into a single string. Then, if your string text covers several lines, there are several lines, and if you want to retain the formatting, preserve the exact formatting you use while typing it in, then use triple quoted strings. So this is triple quoted string. So this is beginning of string, and then these are the these triple quotes means preserve the format. This triple quote starts from here triple quote ends over here. And in between, this is string 1. So this double quote is for the string 1. It will end over here. Then you press enter and then string 2, 3, 4, 5, 6, 7. After that, triple quote. You can see here that the format is retained because of this triple quote. This is the use of triple quote. So for string, single quote is allowed, double quote is allowed, triple quote is also allowed. Next is this \t/n is. So for this, how many characters are there? What is the length of this x? So this and is means 4 plus 2, 6 characters are there. Then why the length is 9? Because we know that this \t means tab and \n means new line, but it treats this as single character. So \t is one character. 4, this is 5, 6, 7, 8, 9. So that's why answer is 9. Then can anyone tell the answer for this? S is equal to Monty. S of 1 colon minus 1. Reply in the chat box. S of 1 colon minus 1. Very good, very good. ONT is correct answer. ONT is correct answer. 1 colon minus 1, ONT. So we can use forward as well as reverse indexing in combination. It is allowed. It is allowed. It is reverse indexing. So allowed. Next is you can also access each character via tuple unpacking. This feature is not used often because you have to use exactly the same number of variables as characters in a string. So here we have one string, and in this string there are 3 characters. So we can use a, b, c to capture them. So y will go to a, e will go to b, s will go to c, like that. So this program is written in Python 2, so that's why bracket is not there. In Python 3, we use the bracket. Next is formatting strings. So modulo percentage operator has special behavior. So its percentage d means this integer will come 7. Past percentage d means next integer. Okay. And then percentage s means string will come here. So it's 7 past 9 read. So this will be the output for this. Okay, so this percentage, these are the percentage C, percentage D, percentage F. They come from C language. So this is the table for them: F, D, S, C, U, X, O, E, G, R percentage, like that. Next is you can call the list of sequence to convert any sequence type to a list. Like over here, there is one tuple. In tuple 5, 10, these are the element. So if you apply list of function on this tuple, you will get 5 and 10 as elements of a list. So you want to convert a tuple to a list, it is possible. Okay. And then list of the bird. So this is a string. So we can have each character is a separate element of a list. If you call a list on an object that is already a list, you will get a copy of original list back. Next is list comprehensions. One final way to create list is through list comprehensions. Like for x in range 1, 11. So range function, it will start at m, it will go up to n minus 1. If this is n, it will go up to n minus 1. So 1 to 10 is the valid range. So it will pick up each element from this. Like first 1 is picked up, then 1 square is performed. 1 square is 1. Then next is 2. So 2 square, 4, 3, 9, 4, 16, like that. 1 to 10 are the valid elements. So 1 to 100 is the output. So we can generate list in this way. And if you want to retain only even numbers, even squares, then also it is possible. If the number is even, then only find the square. That is also possible. Then for OP in sin cos tan colon, print OP. Suppose this is the function, this is the for loop where the print function is written. Then this for loop, what it will get each element. So for first iteration, it will get sin. OP value will be sin. It will print it. Next iteration, it will get cos. Next tan. Okay, one by one, it will print the elements of this list. Then this map function and lambda function, we are going to discuss them in lab session, because here it is not possible to clarify these things in detail. There we will perform hands-on exercise and we can clarify those concepts. So with this, these were the typical things in Python. So today we discussed about various types of agents, and we discussed about typical things in Python which are important for coding. So with this, we'll stop here. Any doubt, any query?
No, sir.
Okay, we'll download the attendance list and then you can log out. Thank you for attending the lecture. Bye bye.